All right, let's dive right in. Today, we're going to be cosmic tour guides. We're heading out into the wild expanse of space to learn how to spot and identify the incredible creatures that live there, the galaxies themselves. Think of this as your very own field guide to the cosmos. So just to set the scene, that number you're looking at, that's 2 trillion. That's the current best guess for how many galaxies there are in the part of the universe we can actually see. It's a number so big, it's kind of hard to even wrap your head around, right? Each one of those is its own universe of stars, gas, and dust. So yeah, with trillions of them out there, how in the world do astronomers even begin to get a handle on it all? How do you organize that much cosmic chaos scattered across billions and billions of light years? Well, the answer is actually pretty elegant and surprisingly simple. It all starts with something you can see right through a telescope: their shape. Their visual appearance, or what scientists call their morphology. That's the very first clue to figuring out what a galaxy is all about. And before we get to spotting, let's just make sure we're all on the same page. What is a galaxy? It's this massive system of stars, leftover star bits, gas, dust, and that super mysterious stuff called dark matter, all held together in one giant gravitational hug. That's the basic recipe for everything we're about to see. Okay, so how do we sort them? Well, for that, we can thank the legendary astronomer Edwin Hubble. He came up with a classification system based on what these galaxies look like. It's called the Hubble sequence, and you know what? It's been our main cosmic playbook for almost 100 years now. And honestly, we can boil the whole system down to 3 pretty simple steps. First, you look for those classic, gorgeous, swirling arms. No arms? Okay, step 2. See if it's just a smooth, kind of oval-shaped blob. And if it's not one of those two, well, you've probably found yourself an irregular galaxy. It's a great starting point. So let's zoom in on the 2 big players in the galaxy world, the spirals and the ellipticals. These 2 families, they make up the huge majority of the big galaxies we see sprinkled throughout the universe. First up, the ellipticals. I like to think of these as the calm, quiet giants of the cosmos. They're basically these smooth, featureless balls of stars. They get classified on a scale from E0, which is almost a perfect circle, all the way to E7, which is stretched out more like a football. And then you've got the spirals. These are the showstoppers. They're defined by that flat, spinning disk with those bright, beautiful arms sweeping out. They get sorted from Saggia, which have a big central bulge and really tight arms, all the way to SC, with tiny centers and these magnificent, sprawling, wide-open arms. Now, this is where it gets really interesting. Their shapes tell us about what's happening inside. Ellipticals are packed with older, more evolved stars and have almost no gas and dust left, which means their star-making days are pretty much over. But spirals, they are loaded with gas and dust, especially in those arms, making them these bustling, active nurseries for brand new stars. Oh, and there's a super common twist on the spiral design. A whole bunch of them, including our own home, the Milky Way, are actually barred spirals. It just means there's this straight bar-shaped line of stars cutting through the middle that the arms branch off from. Yep, that's us. We live in a barred spiral. But, you know, the universe doesn't always like to follow the rules. So what about the galaxies that just don't fit into these neat little boxes? Well, that brings us to the rebels, the outcasts of the cosmos, the irregular and peculiar galaxies. Irregular galaxies are pretty much what they sound like. They're a mess. They don't have a defined shape. No spiral, no ellipse, just chaos. Often, their weird shape is the result of getting yanked around by the gravity of a bigger neighbor. The Magellanic Clouds, which you can see from the southern hemisphere, are 2 famous examples hanging around our own Milky Way. Now, a little different from irregulars are the peculiar galaxies. These aren't really a separate class, it's more of a description. They might have started as a normal spiral or elliptical, but then something dramatic happened. They have these really weird features, like rings of stars or these long, streaming tails. These are basically the battle scars from cosmic collisions, 2 galaxies merging in a process that can take hundreds of millions of years. So we have all these shapes and types, but what does it all really mean? Well, it turns out that a galaxy's shape is so much more than just a label. It's like a snapshot of its entire life story. When you look at a galaxy's shape, you're really looking at its history. You're seeing clues about past collisions, you're seeing what it's doing right now, like how many stars it's making. You're basically reading its biography. So let's look at our 2 main types again with that in mind. The ellipticals, they're like these quiet, retired cities. They're full of old reddish stars because they've already burned through all the fuel they need to make new ones. But spirals are like booming, growing metropolises. Their arms are lit up with bright, young blue stars, a dead giveaway that they are still very much in the business of creating. I think this quote just nails it. A galaxy's shape is its biography, written in starlight. Every single curve of a spiral arm, every smooth glow of an elliptical, it's all telling a story, a grand story of how it was born, how it lived, and how it interacted with its neighbors. And that brings it all right back home, to us. We live in a spiral galaxy, a place that is alive and kicking, actively making new stars. Its amazing shape tells us we're part of a dynamic, evolving system. But that leaves us with a pretty big question, doesn't it? What does that mean for our future? What kind of cosmic story is still waiting to be written for our home galaxy?